Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about projections of oblique lines. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now an oblique line is the one which happens to be inclined to both the reference planes, that is horizontal plane as well as the vertical plane. Therefore, an oblique line, it is a straight line that is neither horizontal nor vertical. So, an oblique line, it will be inclined to both the reference planes. Therefore, neither the front view nor the top view, they will be parallel to the XY reference line. And since an oblique line, it happens to be inclined to both HP and VP, therefore, the projections of the oblique line onto the reference planes HP and VP, they will be obtained as apparent lengths, and we will not be able to obtain the true length of an oblique line onto the reference planes HP and VP. And since an oblique line happens to be inclined to both HP and VP, therefore the intersection of the oblique line itself or its extension with the reference planes, they will be providing us the traces of the line, that is horizontal trace as well as the vertical trace. And the traces, that is horizontal trace and the vertical trace, will be obtained by the extension or the intersection of the line with the horizontal planes, and these traces, they are drawn through the projections in the front view as well as the top view. That is, the projections in the front view will be A dash, B dash, and the projections in the top view will be AB. And we must note that the traces, they are drawn through projection lines A dash, B dash and AB, and they are not obtained through the extensions of the true lengths of the line. Now, let us read out the statement. So here we have been provided with an oblique line AB which is 60 millimeter long. So this means that this line AB, it is the true length of the line, right? So this line AB happens to be 60 millimeter long. So we have got A dash, B1 dash or AB2, it is equal to 60 millimeter. And A of the line, it is lying 15 millimeter above the horizontal plane and 20 millimeter in front of the vertical plane. So it means that end A of the line, it is lying in quadrant number 1. Similarly, the end B of the line, it is lying 35 millimeter above the horizontal plane and 60 millimeter in front of the vertical plane. So end B of the line also lies in quadrant number 1. So we are required to draw the projections of the line AB and show its inclinations with the reference plane. And we are also required to evaluate the traces, that is horizontal trace and vertical trace of the line AB. So let us start with the construction of the projections of the oblique line. So we have got the XY reference line. So we know the location of the end A of this particular line. So end A of this line, it is lying 15 millimeter above the horizontal plane and 20 millimeter in front of the vertical plane. So here we have got end A, it is lying 15 millimeter above the horizontal plane. So therefore the front view of this end A, it will be observed at a distance of 15 millimeter above the XY reference line. So here we have got the front view of the end A. Similarly, the end A, it is also lying 20 millimeter in front of the vertical plane. So when we are going to look from the top at this particular end A, so we are going to observe that this end A, it will be lying 20 millimeter in front. So it means that this distance we have to draw below the XY reference line. So the top view of the point A or the end A, it will be lying 20 millimeter below the XY reference line. Now let us move on to end B. So we have been provided with the information that end B of the line, it happens to lie 35 millimeter above the horizontal plane. So we are going to mark this distance equal to 35 millimeter above the horizontal plane. So this is 35 millimeter above the horizontal plane. And this is the locus line corresponding to the end B we have drawn in the front view, right? Similarly, the end B, it is lying 60 millimeter in front of the vertical plane. So we are going to measure this distance of 60 millimeter in front of the vertical plane, and we will be marking this distance below the XY reference line. And now we are going to draw once again one locus line which will be at a distance of 60 millimeter from the vertical plane. Now, having obtained the locus of the end B in the front view and the locus line corresponding to the top view projection of the end B, now we know that the true length of the line happens to be 60 millimeter. So since this true length is available with us, so we have got this distance over here corresponding to A dash, B1 dash, it is equal to 60 millimeter. Similarly, AB2, it is also equal to 60 millimeter. Now we can mark this distance of 60 millimeter because origin point, that is A point, was already fixed over here. So this was logged location of the point A. Now we want to locate end B of this line so that we can locate the true length of the line over here. So I know that the true length of the line happens to be 60 millimeter. Now I'll mark this distance starting from point A dash and onto the projection line, which is at a distance of 35 millimeter above the horizontal plane. And once I mark this distance, so this is the true length 60 millimeter, I will be able to obtain the point B1 dash. So I am able to obtain true length of the line A dash B1 dash in the front view. Similarly, I know that the true length happens to be 60 millimeter. So this true length I can project onto the top view of this construction over here. Now, in order to mark this distance in the top view with A as the center, I will be opening my compass equal to 60 millimeter and mark this distance of 60 millimeter starting from A up to the locus line of the end B, which happens to lie at a distance of 60 millimeter in front of the vertical plane. Now once I obtain this point, so I will say that this is my point number 2, and the moment I mark this point number 2, now the orientation of the true length of the line in the top view has also been obtained over here, right? So this true length, it is equal to 60 millimeter. So now this true length has been projected in the front view projections. This true length has been projected in the top view projections, and having projected this true length in the front view projections, now I know that the orientation or the inclination of this true length with respect to the horizontal plane happens to be at an angle theta. So I can mark this angle theta. So I can just write it down over here. So once I mark this angle theta, it means that I have been able to obtain the inclination of the true length of the line with respect to the horizontal plane. Similarly, having obtained this true length in the top view, now I will be able to find out this angle phi. So angle phi, it is the angle of inclination of the true length of the line with respect to the vertical plane. Now next thing I need to do is to evaluate the projections of the line. So I know that true length is available to me in the front view, true length, it is available to me in the top view. Now I want to obtain the projections, that is A dash, B dash and AB of the line in the front view as well as in the top view. Now I know that whenever I have got the true length of a line available with me in the front view, so I am going to use this basic fundamental of the projections of the line. Whenever I have got the true length of the line available with me at an angle theta in the front view, now the projections if I take down, so the perpendicular projector from B1 dash onto the locus line of the point A. So I am going to drop a perpendicular starting from the point B1 dash till I reach this point, that is the horizontal locus line of the point A over here. So it means that I'll be able to obtain this apparent length of the line in the top view. So I can say this is apparent length of the line in the top view. So once the apparent length of the line in the top view, it happens to be parallel to the vertical plane. So on the vertical plane, I will be able to obtain the true length of a line. Now since true length is already available with me, so I know that in the opposite view, that is on the plan side, the apparent length of this line will be parallel to the vertical plane. And once I am able to reach this position, now I'll be using A as my needle point, open compass equal to AB1. I'll be opening the compass equal to AB1 and transfer this distance over here equal to AB1 onto the projection line or the locus line corresponding to the point B2 over here. So this is the locus line corresponding to the point B2 which was provided to us. Now once I draw this arc, now please check, I am also going to mark the arrows over here which will give me the idea about which way this construction is proceeding, right? So first of all, I had drawn a perpendicular from B1 dash to B1, then open compass equal to this much and draw an arc back over here till you reach the projection line or the locus line corresponding to the point B2. Now this point will be point B. So point B is, it is the end point corresponding to point B which represents the apparent length of this particular line which is viewed by the observer from the top view. So AB projection has been obtained over here. So it is the projection of the line while the observer is going to view this line from the top view. So this is the apparent length and this is the true length, and we can see true length of the line happens to be larger than the apparent length of the line. Now having obtained this apparent length, I can obtain the angle of inclination of this apparent length in plan with respect to the vertical plane. So this is the angle of inclination of the apparent length in plan, that is AB, with respect to the vertical plane. And another thing we need to observe, apparent angle beta, it will be greater than the true angle phi over here. So the true length is greater than the apparent length and the apparent angle will be greater than the true angle of inclination. Now let us proceed to evaluate the apparent length of the line in the front view. So I also know that whenever I have got the true length of a line available with me in the top view projections over here, so this is AB2. Now what I have to do, on the opposite side, I'll be dropping a perpendicular from the end point, second end point of this true length onto the locus line of the point A dash over here, so that this apparent length, it should be parallel to the horizontal plane now. So once the apparent length in elevation, it is parallel to the horizontal plane. So on the horizontal plane in the top view, I am going to obtain the true length of a line. Now since true length is already available with me, what I am going to do, from the second end point of the true length, that is B2, I am going to draw a perpendicular. So now please check this arrow. I am moving from this point B2 up to the horizontal locus line corresponding to point A dash over here. Now onto this locus line, I will be obtaining a point. This will be point B2 dash. So B2 dash and B2, they will be falling in one vertical line. It is a vertical projector. Now I have been able to obtain the apparent length of the line, which is a horizontal line over here, which is parallel to the horizontal plane. Now having obtained the apparent length of the line over here in the front view, I'll keep this as my needle point. This will be my pencil point. Open compass is equal to this much and draw an arc so that you can reach the locus line corresponding to the point B1 dash over here. So starting from here, this is my needle point, this is my pencil point. I'll draw an arc. Now again, arrow I have marked over here, that is I am going to move from this direction to this direction, and this arc has to be extended up to the point till this arc is going to intersect with the horizontal locus line corresponding to the point B1 dash over here. Now I am able to obtain B dash point. So this point B dash has been obtained in the front view. Now a vertical projector line needs to be drawn from point B up to the point B dash. So if both of these points B dash and B, they happen to lie in the same vertical projection line, it means the construction that we have made, this construction is accurate and this is acceptable. So once I am satisfied that points B dash and B, they are falling on the same vertical projector, now I can join A dash with B dash. That is the projection of the line in the front view, that is the apparent length of the line in the front view has been obtained. So this is the apparent length of the line which is visible to the observer when the observer is going to look at this line from the front view. Now having obtained the apparent length of the line A dash B dash, we need to evaluate the inclination of this apparent length in elevation with respect to the horizontal plane. And we can see that the angle of inclination of the apparent length in elevation A dash B dash with the horizontal plane, it happens to be angle alpha over here. Now we can check the true length of the line in elevation, it is 60. Apparent length of the line, it happens to be shorter than the true length of the line. Another thing we need to observe over here, the apparent angle of inclination of this line with the horizontal plane, that is angle alpha, it is greater than the true angle of inclination of this line with the horizontal plane, that is angle phi. So the apparent angles alpha, it will be greater than theta. Similarly, apparent angle beta, it will be greater than phi, whereas true length will be greater than the apparent length. So having obtained the projections of the line and the angles of inclinations of this oblique line with respect to the horizontal plane as well as the vertical plane, now we are going to proceed with evaluation of the traces of the line. And in order to obtain the traces of the line, we must check whether the projection lines A dash, B dash and AB, whether they are intersecting with the XY reference line themselves. No, they are not intersecting with the XY reference line. So what we need to do, we need to extend or project the A dash, B dash projection line till it meets the XY reference line over here. And wherever A dash, B dash projection line, it meets the XY reference line, we obtain the point H dash over here. Similarly, AB projection line, that is the top view projection line, it is also not intersecting with the XY reference line. I have extended the projection line AB over here. Now, wherever this projection line, it intersects with the XY reference line, I obtain the point V over here. Now, having obtained the point H dash and V, now the vertical projectors need to be drawn from the points H dash and V so that they should be intersecting the projection line which is coming from the opposite view. So this is the projection line from the elevation view. I have drawn a vertical projector line so that wherever it intersects with the extension of the plan projection line, I will be able to obtain point H, and this will give me the measurement of this distance. It will give me the horizontal trace of the line. So I'll be measuring this distance and this distance will be giving me the horizontal trace of the line. Similarly, the plan projection line AB, it happens to intersect the XY reference line at a point V. Now from point V, again I am going to draw a vertical projector line and extend it till it meets the elevation projection line itself or its extension over there. Now I find that once I draw a vertical projector through the point V, so it will be intersecting with the extension of the elevation projection line at this particular point, and this point will be called as point V dash, and the distance between V dash and V, it will give me the vertical trace of the line. So I'll be measuring this distance, this will be equal to vertical trace. I'll be measuring this distance and this will give me the horizontal trace of the line. So with this, we have been able to evaluate the projections of the line. We have been able to evaluate the inclinations of the true length of the line with the horizontal plane as well as the vertical plane. And besides this, finally we have evaluated the horizontal trace and the vertical trace of an oblique line. I hope that through this discussion you would have understood about the procedure to evaluate the projections of the line when the true length of the line alongside the orientation of the line with respect to HP and VP is available with us. So this is all for today. So we'll continue with further discussion regarding few more cases on the oblique line projections in the coming lecture. So thank you very much. Thanks a lot.